I did a whole lesson, almost 16 minutes, without turning on the video. Remember I told you, 873. Losing it a bit. Then I realized I have to do it again. Well, today I'm going to do a bit of inverse trigonometric functions and then go over differentiation of inverse trig functions. As I told you, inverse trig functions are in every syllabus, but the derivatives and the integrals, I think it is OCR and AQA, it was at least the derivative and a bit of integration was there initially in Excel, but within the first year they decided no, we don't want it, and they moved it to for the maths. Okay, so you remember, let's recollect. For a function to have an inverse, it must be 1 to 1, meaning for every value of x, there must be only one value of y, and for every value of y, there must be only one value of x. And the domain of the original function becomes the range of the inverse function. The range of the original function becomes the domain of the inverse function. All these things we have gone through. So let's look at the function. Let's call this as a 1. Let's call this as part A, f of x equal to sin x. If you look at the graph of sin x, if I draw a line parallel to x-axis, there are going to be infinitely many values of x, for which there is one value of y. So it is a many to one function, does not have an inverse. But still we talk of f inverse x. So what we do is we restrict in that way. Don't you see, if you draw lines parallel to x-axis, they cut the graph in only one point each, it becomes 1 to 1. So minus pi over 2 less than or equal to x less than or equal to pi over 2. Within that particular range, now I forgot to start the clock, stopwatch. Within that particular domain, it is 1 to 1. Then f inverse of x is arc sin x or sin inverse x, not sin x whole power minus 1, that becomes cosec x. And then the domain for this is minus 1 less than or equal to x less than or equal to 1. The range is minus pi over 2 less than or equal to arc sin x less than or equal to pi over 2. You must know the definition, you must know the domain, you must know the range, you must know the graph. So the graph, I'm not good at drawing, as you will have noticed by now. Let me try and see if I can make, this is 1, 2, that's 1.57, which is pi over 2, that is 1, that is 2, that's pi over 2, that is minus 1, that's minus 2, I don't need it, so that's minus pi over 2, that's pi over 2, minus 1, minus 2, that's minus pi over 2, right? Let me draw at sin x, at pi over 2 it is 1, at minus pi over 2 it's minus 1. Let me, minus pi over 2 is somewhere here. I draw the line y equal to x. Y, remember, a function and its inverse are reflections of each other in the line y equals x. So let me draw sin x here. Oops! No! What did I do? What did I do? So this is the graph of sin x. Yeah? This point being minus pi over 2 minus 1, that point being pi over 2 1, that is sin x. This point is 1 and pi over 2. This point is minus 1 and minus pi over 2. Yeah? Sorry. Me and my graph. I told you, I'm not good at drawing graphs. This is there. So the graph of sin x is like that, where the line y equal to x. I need to put the line y equal to x somewhere here. Right. This one is minus 1 minus pi over 2. This graph is like that. This is pi over 1 and pi over 2. This is minus 1 and minus pi over 2. Yeah. And remember, sin inverse x is an angle, whereas sin x is a ratio. So you're expected to know the definition, you're expected to know how to draw the graph. At Excel, others need to know differentiation as well, which we'll take up a bit later. So let me get rid of the sin x graph. So now the second one is f of x equal to cos x. Then again, same problem with cos x. Whereas if I were to restrict this from there to there, you can see it becomes 1 to 1 in this region. That's the reason why, if you take your calculator and do sin inverse root 1 over root 2, you get pi over 4. You do sin inverse minus 1 over root 2, you get minus pi by 4. Whereas, if you do cos inverse 1 over root 2, you get pi over 4. But cos inverse minus 1 over root 2 gives you 135 degrees or 3 pi by 4. Because sin inverse x, the range is from minus pi over 2 to pi over 2. Whereas cos inverse x, the range is from 0 to pi. Your calculator uses the principal value. Yeah? Okay? So then f inverse of x is, so this is 0 less than or equal to x less than or equal to pi, or cos x or cos inverse x. The domain is minus 1 less than or equal to x less than or equal to 1, and the range is 0 less than or equal to arc cos x less than or equal to pi. Remember, arc cos x, arc sin x are all angles, cos x and sin x are all ratios. As usual, you should know the graph. This graph is more difficult to draw, so I'll make it a bigger graph for you to understand. Let's say that is 1, that is 2, nah, that's too big. Nah, 1, 2, 3, that is 5. 1, 2, 3, that is 5. Yeah, minus 1, and this is minus 1. Cos of 0 is 1. Cos of pi over 2 is 0. And cos of pi is minus 1. So the graph of cos x, I use red, yeah? So let me use red. So the graph of cos x is like that. Now this is like this. This is pi and minus 1, pi over 2 and 0. This is y equal to cos x. As usual, I'll take 1, 1. I'll take minus 1, minus 1. Draw the line y equal to x. 1 and 0. I'm looking at cos inverse now. And then 0 and pi over 2. Minus 1 and pi. I'll put 0, 1 later there. This is 0, 1. So that graph, I will write 0, 1 later. Oh my God. It becomes a mess. Let me remove that. Okay. So this graph goes like this. That will be minus 1 and pi, 1 and 0. This is cos inverse x. You should know the graph of cos x. You should know the graph of cos inverse x. Well, you know the graph of tan x, so I'll just show you the graph of tan inverse as well. Yeah, part C is f of x equal to tan x. The domain is minus pi over 2 less than x because it's an asymptote. Then f inverse of x is arc tan x. Domain x belongs to R. Range minus pi over 2 less than tan x, arc tan x less than pi over 2. This graph again is a bit of a problem. That is 1, that is 2, that's pi over 2. That is minus 1, oh no, that's minus 1, that is minus 2, so that's minus pi over 2, that's pi over 2. Those are the asymptotes. Okay. Then minus 1, minus 2, so that's minus pi over 2. That's 1, that's 2, that's pi over 2. Okay. I'll draw the line y equal to x. So your tan x graph, tan of minus pi over 2 is negative infinity, so it joins there and it goes to positive infinity. The arc tan x graph let me put the asymptotes in blue. The arc tan x graph looks like that. Okay. So as far as Edexcel students are concerned, you should know this. The graphs, the definitions, and the domain and the range. We need to do differentiation of these three. Okay. This is where maybe there are so many ways of doing it. Let me show you. Here I can say derivatives of. Find dy by dx when y equal to arc sin x. So the only thing you can do is x equal to sin y, dx by dy equals cos y, yeah, which is root of 1 minus sin squared y, which is root of 1 minus x squared. So d by dx of arc sin x equal to, so dy by dx is 1 over root 1 minus x squared. Suppose you take y equal to arc cos x. So I can say x equal to cos y. Dx by dy is minus sin y, which is minus root 1 minus cos squared y, which is minus root 1 minus x squared. So dy by dx is minus 1 over root 1 minus x squared. And the last one, y equal to arc tan x equal to tan y, dx by dy equal to sec squared y, which is 1 plus tan squared y, which is 1 plus x squared. So dy by dx equal to 1 over 1 plus x squared. You should know how to find the derivatives. In the next lesson, those who want to, you can add all these three extra formula in your formula sheet. And next lesson, I will do some questions on differentiating arc tan, arc sin, arc cos. Okay? Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.